Hello and welcome to the Friday, March 7th, 2025 edition of the SANS and its Storm Center's Stormcast. My name is Johannes Ulrich and today I'm recording from Baltimore, Maryland. Well, we all know it's important to keep your browsers up to date. Last week, Google did release a new update for Google Chrome. Unfortunately, they're sort of doubling down on getting rid of older extensions that are still using the version 2 of their manifest. The problem here is that these older extensions had more privileges to interact with Chrome, which Google no longer wants to allow. However, there are also some beneficial extensions that took advantage of this access. One that's very vocal here is UBlock Origin. UBlock Origin now in this latest update is automatically being deactivated. And then if a user is trying to manage their extensions, well, they're kind of pushed in the direction of actually uninstalling and removing this extension. The problem is, well, you don't actually have to remove it. You are able to reactivate it for now. Just Google doesn't make that very obvious. This has been an ongoing battle between sort of UBlock Origin and Google. Not 100% sure if UBlock Origin could come up with other ways to do its work and block advertisements. Of course, one of the suspicions here is that Google's reliance on advertisement revenue makes them more likely to actually prevent users from running these type of extensions in their browsers. And we have some critical updates to talk about. First of all, Kibana. Kibana, of course, is also part of our honeypot theme. It's the popular dashboard for Elasticsearch, and it suffers from a prototype pollution vulnerability that could allow arbitrary code execution. In order to exploit the vulnerability, an hacker would have to have access as viewer to the dashboard. Now, this is, of course, a low privilege account usually, and often provided without password or with well-known password, just to allow users to, for example, review a particular public dashboard. So updated, there's also a quick workaround that you can enable. I'll link to the advisory from Kibana in the show notes. And Wired has a story, that we have sadly seen before, and that's Android web TV devices that are showing up with pre-installed backdoors. These are commonly known sort of as TV stick devices, usually just a little HDMI plug that you plug into your TV, maybe some USB for a power supply. But yes, these devices come with adware and the like pre-installed, and apparently just another batch has been found with about 1 million or so compromised devices. Not too much really you can do about this other than, be careful where you're buying these devices from, and also probably not necessarily going to the cheapest device out there from any kind of no-name supplier. Well, and it's Friday, and I do have another SANS.edu student to interview here. Eric, could you introduce yourself, please?
Sure. My name's Eric LeBlanc. I'm a senior cybersecurity engineer at the U.S. Strategic Petroleum Reserve. And my paper was on a new technique that I developed for attempting to detect advanced persistent threat actors within an environment.
Yeah, so advanced persistent threat actors, of course, one thing they try to do to stay persistent is not to get detected. So what was the new technique that you came up with there?
So here I created a thing that I call meta detection. So it examines your detections over a longer period of time than you might traditionally look at for detections. It works similar to how risk-based alerting works in that you're looking at things over time. However, specifically what I was looking at was tracking things using the MITRE ATT&CK framework and specifically known TTPs that have been used by specific threat actor groups. So effectively trying to identify known actors that might be specifically looking for a given enterprise. So it requires you to go through a good threat modeling process to know what actors might actually be targeting you, as well as understanding their tradecraft and what they're doing. But specifically, it's looking at how they have acted in historic intrusions and trying to connect dots within your environment.
Okay, cool. So let's make it a little bit more specific. What was one of the threat actors that you selected there?
Yeah, so specifically, I was looking at APT29 for the experiment that I conducted because they're a fairly well-known and well-researched entity already. And we had a very large history to pull from and look at for their potential techniques. And it was interesting. It in my experiments, it showed as effective as risk-based alerting, which was a bit of a surprise to me.
Yeah, and so what was like one of the indicators or TDPs that you sort of looked for here?
Yeah, so specifically, we were looking at things that they'd done historically. So we were looking at some of the same lateral movement techniques that they were using, like via remote management or Windows administration tools, things like that. We were looking for all of these various sub-techniques that they had done in the past, but we were looking to connect them within the environment over a history. So basically, one of the problems we had found with risk-based alerting is that you need to set that threshold because there's going to be some amount of noise. Administration tools look a lot like hacker tools many times.
Yeah.
So basically, a problem can be filtering the noise from what is normal behavior. One of the things that I found was that normal behavior doesn't strictly follow the known plan of an APT actor in many cases. So it was easier to say, okay, well, I see this execution activity, and then I've later, weeks later, okay, well, then this host I saw execution activity on ended up attempting lateral movement or attempted to do reconnaissance or something like that by unknown method. So like say they were doing SMB enumeration, or they were doing something more specific that is not routinely done within the environment. And linking those things together through a series of detections that are looking at historical data from within the environment.
Yeah, so basically not them exploiting it or doing lateral movement right away, but waiting then for that. Yeah. And that's certainly something that APT sometimes tends to do, sort of as they sort of figure out what they have and don't have. The one challenge that I can sort of think of, that sort of the alarm bell that sort of goes off right away is how to deal with all the data over that amount of time.
So in this instance, I am both gifted and cursed by working in a federal environment. So one of the big OMB memos that came out in recent years involved logging and log retention periods. So by OMB rule, we have to maintain minimum 1 year of logs in hot storage so that we have to have that available to look over, as well as an additional 18 months in archive storage. So at any given time within the environment that I was testing in, we have a whole year of logs to look at. So it's very pricey. It's a luxury that not a lot of entities have. However, per regulatory orders, we have to have that. Okay. So within federal environments, at least, you're going to have those logs.
Yeah, and also the ability to search then, because that's the other cost factor here. Like storage is cheap to some extent, but fast storage that you can actually search with queries like this. Were you able to do some sort of pre-filtering or such to speed that up, or any sort of data management procedures that helped here?
Sure. So in this case, we were querying across the previous detection specifically. So we're not looking at all of the underlying log data. We're looking at the records generated from previously fired detections. So all of that data is pretty small and pretty easily searched through. Specifically, we were annotating within the detection field saying, okay, using MITRE technique IDs and also the kill chain phase that a given detection corresponds to. So from there, you can say, show me all of the detections that fired with actions on objectives as the kill chain phase. And it would then filter out based on whatever your query was, whether you were looking at an individual host, you were looking at the whole environment, things like that. So in this case specifically, I was working within Splunk Enterprise Security. You can do the same thing with other SIMs as well. I know SoftElk, you can have annotations for your detections, and it's not unique to that specific tool, but it was one that we're using in our environment.
Yeah, give us a little bit an idea of the scalability and practicality of this. Can you say approximately, how many logs or how many endpoints or such you're monitoring there?
Yeah, so for this environment, we were looking at approximately, I think it was around 3,000 to 4,000 endpoints total between end user devices, networking equipment, servers, all that. So it's not a small environment, but I would say I think our total number of users is around 12 to 1,300 end users. So not a small business for sure. But it's not necessarily the size of some worldwide enterprises. But in theory, the the logic should scale because you're looking at previously detected events. So you're not having to pour through terabytes of actual log files. You're really only looking at previous detections. So what might be considered either an event of interest or choose your favorite vocabulary for that. But so you're only looking at sort of the summarized events.
And what's of the detection delay then? Basically after the event happened, how long would it take? Is you run these queries daily, hourly, or?
Yeah, so I was running these queries, and at the as part of the experiment, I was running them every 15 minutes. So they run very quickly. It only took, I think, maybe a couple seconds for the actual query to run through. So I was doing them periodically. Over a large enterprise, you may want to scale that up some. It depends on the sensitivity that you're looking for. But because you're going over summarized data, it's much faster.
Yeah, and I guess in a large enterprise, you would also not run it necessarily over the entire enterprise, but some department, some critical enclave or something like that.
Yeah, something that you've identified as part of your, crown jewels analysis or something like that.
Yeah, so that's really cool. You're using this right now in your day-to-day job?
Yes.
Yeah, so great. The link to the paper will be added to the show notes. So if anybody's interested in any more details here and how this all exactly worked, any final words, Eric? Anything to give people on their way to implement this?
Sure. So don't be daunted by how much how much needs to be done beforehand, because this really isn't something that I would expect to work early on in the maturity process for an environment. You need a whole lot of base level skills to make this work. You need to have an active threat intelligence practice, both consuming and producing. You need to have very mature detection engineering that that these individual detections that are firing have good fidelity and have already been tuned well. It takes a lot, and it is a journey. So there's a lot of underlying assumptions there that are required, and the only way to get there is to actually do the work.
Yeah, great, and thanks for being here. Thanks for everybody listening, and talk to you again on Monday. Bye.